Section 6.3 in the curriculum, which is swaption payoffs. When a swaption is exercised, it effectively creates a stream of equivalent payments, commonly referred to in the financial world as an annuity. This stream is a series of interest payments equal to the difference between the exercise rate and the market rate on the underlying swap when the swaption is exercised. Now, this is a reasonably straightforward statement, but to understand this, we need to look at an example. So, consider a European pair swaption. Now, I hope you can, based on what you know already, figure out the difference between a European pair swaption and an American style swaption. A European swaption can only be exercised on the last day, on maturity. Okay. So consider this European swaption that expires in 2 years and is exercisable into a 1-year swap with quarterly payments using 90/360 as the day count adjustment. The exercise rate is 3.60%. The notional principal is 20 million. So what does this mean? This means that if you are here at time 0, we have a pair swaption that expires in 2 years. So the pair swaption expires in 2 years, and the underlying is a 1-year swap. So in the swap terminology, how will we write this? It's swaption terminology. This is a 2/3 swaption. Where does this swaption expire? It expires at the end of year 2. We are told that the exercise rate is equal to 3.6%. Now, for us to benefit from this swaption, what must the rate be at year 2? The rate on a 1-year quarter pay swap. If the rate is more than 3.6%, then this swaption is in the money, and we will exercise the swaption and essentially take this rate. If the 1-year swap rate over here is 3.5%, then what will we do? Then essentially the swaption has expired out of the money, so we will just let it be and we will take on the market rate of 3.5%. Now, just to take this one step further, this is a quarter pay swap, and to make the subsequent slides easier, let's do a simple calculation over here. As you can imagine, the future slides will not be very useful if the swap expires out of the money, so you can guess that the swap will be in the money. So if you do come at this point and exercise the swaption and you get into a fixed rate swap, okay, on this underlying, if you get into the fixed rate swap, what are the quarterly payments going to be? Can you calculate that? So given the fixed rate is 3.6%, all right, and the notional principal is 20 million, how will you do that? So what's the number? Yeah, so you simply, so if that's your fixed rate on an annualized basis, you find 1/4 of that. So take 1/4 of this number and multiply it by 20 million. What do you have? So if you do get into this swap, you will have 180,000 payment every quarter. Okay. Now we are given this additional information. At expiration of swaption, the term structure is this. Now what does the expiration of swaption mean? That, remember, what was we had time 0. What was this time? 2 and 3. So we come 2 years later and we have this term structure. All right. Remember, it's a quarter pay swaption. That's why we are given 4 different rates. If you hadn't gotten into that swaption here, and at this point in time you are now figuring out what the fixed rate should be given this term structure. How will you do that? Yeah, do you remember the formula? So the formula is each of these coupon payments on $1 of notional principal, what will this be equal to? 1 minus Z4 divided by Z1, Z2, Z3 and Z4. And just very quickly, what is Z1? It would be 1 over 1 plus this number divided by 4. 0.0345 divided by 4. Okay. Now that number fortunately is already given. And the reason I did this exercise is when you look at past paper questions and you look at the curriculum, sometimes the discount factors are given and sometimes they are not given. So depending on what the examiner wants to test. So you need to be comfortable coming up with the Z factors, or if they are given, then that might be good news or bad news. Why might this be bad news? Because then you are being tested on some more detailed concept. Okay. So they are assuming that you've gotten here so you know how to come up with discount factors. So we do this calculation, and what will the C value be? So it will be 1 minus Z4 plus all these numbers, and the answer is the C value will come to, it's actually 0.036 over 4. Okay, the annualized rate then on $1 of notional principal, the annualized rate is 0.036 or 3.6%. No. Yeah, actually the correct answer is this is 0.0368 over 4, and when you annualize this, it's 3.68%. So the point is, the market rate for a 1-year swap at this stage, so the market rate is what? 3.68%. If you had gotten into the swaption that we just talked about, where the exercise price is 3.60%, then are you in the money? You are in the money because the market rate is higher than the exercise rate, so you can pat yourself on your back saying that you did a smart thing. So you got into a fixed rate at a rate of 3.6 versus a market rate of 3.68 with $20 million of notional principal. This can be substantial. Okay, now let's now compute let's now look at the various scenarios. Okay, there are one of 4 things that can happen when you get to maturity. So I'll just draw this out for you one more time. So time 0, now we are at time 2. This is where the option expires. So when we are at this stage, now that the market rate was 3.68%, our swap rate was 3.60%. What are the different things that can happen? One scenario, which is scenario A, is that you exercise the pair swaption, entering into a pay fixed, receive floating swap. So at time 0, what did you do? You entered into a swaption. The swaption expires over here, and you exercise that swaption. So what does that? So now you have a swap where you are paying how much? You are paying fixed equal 180,000. This we did a couple of slides ago. So where did this number come from? It was based on your contractual rate of 3.6% and not based on the market rate of 3.68. So based on this, on a quarterly basis, what's your quarterly payment? 180. And every quarter, what money will you receive? So here, end of quarter one, how much money will you receive? You will actually, every quarter, you will receive money based on the floating rate at the start of that period. So this period over here, just let's call it 2.1. So end of quarter one over here, the money that you receive, since you are receiving what? You are receiving floating. So this money that you receive is equal to the floating rate at this point multiplied by 20 million. So notice that on day 90, you know what you will get. But do you know what you will get on day, this is day 180. Do you know what you will get over here on day 180? You don't, because that money depends on the floating rate at day 90. But we don't know that floating rate because we are right now at day 0 of the swap. Okay, so all these future payments are not known. So this is scenario 1, where you simply get into the swap that was underlying the original swaption. The question is, how do we get 172,500? That is the money that you receive. Remember, what was your swap? Your swap was pay fixed, receive floating. So the floating payment that you get here is based on the notional principal of 20 million and the market rate, let's say LIBOR, at this point. What's the market rate at this point? It's 3.68%. So you take at the, yeah, actually, so what's the market rate over here? The annualized market rate. Yeah, right. So this is the at maturity, the 90-day market rate is 3.45 based on 90-day LIBOR. Is this an annualized number? Yes. Yeah, all these numbers are annualized. So this number of 172,500 is based on this 3.45. So into 0.0345 divided by 4. This multiplication is going to give you this number. And then how will we figure out this payment? It's going to be based on the 90-day. So this payment over here is going to be based on the 90-day rate on this day. Okay, so we can calculate these later. All right, what's another scenario? The other scenario is that you exercise the pair swaption. What was the pair swaption? So you pay the pair swaption is pay fixed at what rate? At the exercise price of 3.60% per year, and then we change that into quarters. And what do you receive? So you receive floating. So that's this part. Exercise pair swaption entering into a pay fixed and receive floating swap. So in red, let me just mark the payments associated with this one, because we'll also have another swap which I will make blue. So this red, which is the swap underlying our original swaption, that corresponds to what payments? That corresponds to, so these are our pay fixed numbers. So these are all the pay fixed numbers. And then what are we receiving based on this swap? We are receiving this and these future floating payments. So this red is the original swap that was underlying the swaption. Now what we are saying is, in addition, what we are also going to do is on this day, we also enter into a receive fixed pay floating swap at the market rate. So on this day, we will enter another swap, and you'll see why. So what is this other swap? It is receive fixed, pay floating. Now, how do we figure out the fixed rate over here? Yeah, it is based on the new market rates over here. So I won't make you do this, but given these rates, actually we just did this. Given these rates, what is the C value? So this over 4. So the market rate now for a 1-year swap is 3.68%. So if you actually use that 3.68%, so 3.68%, and on a quarterly basis, how much will you receive? 3.68% divided by 4 for the quarter, multiplied by 20 million notional. So you will actually receive this amount of, so in blue, I am underlining the amounts that you will, the fixed payments that you will receive. And what do you pay? You pay the floating, so that's this number. So you pay the, okay, so you pay floating. Now notice what's happening. You have two swaps. The two floating payments cancel each other out. So notice the 17250. So these in blue, I have marked the payments associated with the blue swap. Right? Do you notice that the floating from the red swap and the floating from the blue swap cancel each other out? Okay, so all the floating payments, this floating, so all these floating cancel each other out. And what are you left with? So effectively you are left with a payment. So you are paying fixed based on 3.60%, and you are receiving fixed based on 3.68%. So what's the net impact? That every quarter you are getting how much? 4,000. Okay, so either you can have a setup like option B, where you are literally making a payment of 180,000 and receiving 184,000 every quarter, or in option 3, what are we doing? We are simply netting. So do you see how option 3 is just a simplification of option C is just a simplification of option B, where we have netted out the two payments and now we are getting 4,000. And okay, let's just finish this. So given this, do you see how we then get this option D? Yeah, so this is, you can say, okay, if with your counterparty, you can say rather than netting off 4K, 4K, 4K and 4K over the next 4 quarters, you just figure out the present value and go home. Okay. So what does this represent? This effectively is the value of that swaption when it expires. And clearly, since the market rate at the expiry of the swaption was more than the exercise rate in the swaption, you won. And you won by how much? You won by 15,643, given a 20 million notional principal. Okay, so now let's continue to section 6.4, and the numbers are behind us. What we are going to talk about is essentially you need to remember these two statements, and I'll just give you the logic of these two statements. A pair swaption is like a put option on a bond. Is this blatantly obvious? Okay, unless you live and breathe these things, it should not be blatantly obvious, but it can be shown rather easily. Okay, so let's take a pair swaption first. What is a pair swaption? This is where you are getting into an option to basically pay fixed. So if you are going to pay fixed, do you benefit if interest rates go up or if interest rates go down? So you benefit if interest rates go up. Okay, so you are pay fixed, so you benefit if interest rates go up. Now, to say that you benefit if interest rates go up, is this the same as saying you benefit if bond prices? So imagine you have bond prices, government bonds, which are fixed rate, so straight bonds, par value bonds. When interest rates go up, that's the same as saying that bond prices going down. So with a pair swaption, you benefit if bond prices go down. Now let's look at a put option on a bond. When you have a put option on a bond, when do you benefit? You benefit when the bond price comes down, okay? Because with a put option, you have the right to sell the bond for, say, par value, and you benefit if the value of the bond goes down. So we'll do a simple numerical example later, but hopefully now you can just remember this. A pair swaption is like a put option on a bond. Now, similarly, we can say that a receiver swaption is like a call option on a bond. Should I do the working or can you do this? Okay, just think about it, write it down, and then I'll do it. Okay, so again the same logic. Receiver swaption means you are receiving a fixed payment. If you are receiving fixed, you benefit if interest rates go down, which is the same thing as saying you benefit if bond prices go up. And if you have a call option on a bond, you benefit if bond prices go up. Okay, so let's look at example 7, which is a rather simple numerical example illustrating what we've just talked about. Calculate the market value of a receiver swaption at the expiration if the exercise rate, so the X is 4%, and the term structure is given right here. This is the term structure at expiration. These are the same rates as in example 4. The swaption is on a swap that will make payments in 180 and 360 days. Notional principal is 25 million. And then we need to show that this payoff is equivalent to that of a call option on a bond. Okay, so let's do the first part. How do we figure out the market value of a receiver swaption? We'll have to figure out the benefit and then find the present value of the benefit. Okay, so the exercise rate is 4%. Now, this is slightly tricky. If I were writing this problem, I would make a couple of clarifications. Normally, when people give a percent, they give an annualized number. Here, this 4%, if you look at the solution, the 4% is a 6-monthly number. Okay, otherwise this 4% just wouldn't go with the annualized rates of 8%. So strictly speaking, they should have pointed it out, but they didn't. I am pointing it out for you. So this 4% is a 6-monthly number. Okay, now do you recall how do you come up with a fixed rate? And we are doing this for the 5th time, so by now you should have this memorized. So this is where we are. Okay, so time 0, 180, 360. The swaption has expired, and the swaption had an exercise rate of 4%, and actually what this 4% is the semi-annual number. So this means that on $1 notional principal, you are getting 0.04, and it's a receiver swaption. So you are going to receive 0.04 and and receive 0.04 plus $1 notional. Okay, now you are receiving this much. If you hadn't gotten into the swaption, if you didn't have this exercise price, then do you recall, based on our C values, what did we have over here? 0.0392 and 1 plus 0.0392. Okay, so have you benefited? Yeah, you are receiving more. Because of that swaption, you are receiving more. If you hadn't gotten into that receiver swaption, how much would you have received here and here? These 0.0392 and 1.0392. But because you got into the receiver swaption, how much are you getting? 0.04 and then 1.04. So what is the value of this swap? You can look at this difference and this difference, and then what will you do? Then you will bring it to the present value. This will be for $1 of notional principal. And then what will you do? And then you will multiply by the notional amount of 25 million. So I will have you do that conceptually. As long as you've understood the concept, the rest is just the mechanics of doing it. Okay, now what about the second part? So that we'll do on the left. Show that this pay, actually let me just write the payoff number in case you are doing this online and don't have the problem in front of you. When you figure out the present values, what you should get, the benefit should be 0.0015, and if you multiply this by the notional principal of 25 million, what you should get is $37,500. Okay, now we are being told that we need to show the equivalence of this with a call option on a bond. Okay, so the way you can think of this, actually again they've not specified this, but whenever you have a call option, you need to be given the exercise price. Have they given an exercise price? In the problem, where's the exercise price? The 4% is the exercise price on the swaption, and that 4% represents the rate on the underlying swap, the fixed rate on the swap. But they are asking us to show that this payoff is equivalent to that of a call option on a bond. If you have a call option on a bond, do you need a strike price, which is the price at which you have the right to buy the bond? You need that, but it's not given. When it's not given, what do you assume in such a situation? That the strike price is par value. Okay, so for $1 notional principal, the exercise price or the strike price is 1. It's par. Okay, then the other thing that they haven't given you, which once you have some practice you can do it, is on the bond, what's the coupon rate? And is this a semi-annual, or what sort of a bond is it? Okay, in this setup, the coupon rate is 0.04 on $1 of notional principal. The coupon rate is the same as the exercise rate on the swaption. So it is 4 cents every 6 months, okay, or every 180 days. Okay, now how does a call option have value? When the price of the bond is more than the exercise price. So the way you look at this is, if this were a bond, or actually treating it like a bond, what is the payment that you are getting? 0.04 and then 1.04. If you take these interest rates and come up with the price of a bond, you did this in your basic level 1 fixed income. So given these spot rates and given these cash flows, the price of the bond will be 1.00 0.015. So do the calculation, this will be the price of the bond. If this is the price of the bond over here and your call option gives you the right to buy the bond at par, what's the payoff per $1 of par value? 0.0015, which is the same number as this. Multiply by 25 million notional principal and you get the same answer. Okay, so this is just literally half a page in the curriculum, so it's the concept more than the quantity of calculation. Okay, so we are done with the numerical part. Now just the final ramp down, relatively simple stuff. In section 7, what I have done is I have simply taken the last two learning objectives which deal with this section in the curriculum, and then I have taken the relevant parts from the summary, and I am confident that as long as you know these points from the summary, you know what you need to know for the exam. So let's look at the learning objective and then what we see in the summary. Evaluate swap credit risk for each party during the life of the swap. Distinguish between current credit risk and potential credit risk, and explain how swap credit risk is reduced by both netting and marking to market. Okay, so we are going to cover all these points. The first point is the difference between current credit risk and potential credit risk. Okay, this is from the summary now. Credit risk arises in a swap due to the possibility that a party will not be able to make its payments. Current credit risk is the risk of a party being unable to make the upcoming payment. Potential credit risk is the risk of a party being unable to make future payments. Credit risk is faced only by the party that is owed the greater amount. Okay, fairly simple. Just read this a few times, there is no rocket science over here. So credit risk, who faces credit risk? It is the party that needs to receive money from the other party. So it is as simple as that. Current credit risk is what? The risk of not getting the next payment. And potential credit risk is the risk of not getting the payments after that. So fairly obvious. Okay, now what this talks about is credit risk in different kinds of swaps. What are the three kinds of swaps that we've talked about? We talked about interest rate swaps. We talked about equity swaps. And we talked about currency swaps. And there's a reason why I have written these in this order. Let's first talk about interest rate and equity swaps. The credit risk in an interest rate or equity swap, so these are bundled together, is greatest during the middle of the swap's life. The risk is small at the beginning of the swap because the parties would not engage in the swap if the credit risk was significant at the start. The risk is low at the end of the life of the swap because of the small number of remaining payments. Okay, so just to summarize, if you have, say, a 2-year swap, quarter pay, so you have 8 quarters, all we are saying is, if the credit risk of the counterparty is high, would you get into a swap? No. So we say that the risk is low over here. The risk goes to a maximum middle of the swap, and then since interest rate and equity swaps are generally based on netting off, then towards the end of a swap, the amount of payment that one party needs to make to the other is relatively low. If the amount owed is small, then the credit risk is small. Bottom line for you to remember that for interest rate swaps and equity swaps, credit risk is highest in the middle of a swap. I've seen multiple choice questions on this where if you know this fact, it will be easy to remember. You'll have a simple question that will say, credit risk for an equity swap is most at the start of a swap, middle of a swap, end of a swap. If you remember this point, it will be easy to answer. If you don't remember, then you have a 33% chance of getting it right. Okay, with a currency swap, the key difference is, which you recall from level 1, I hope, that with a currency swap, we don't net off. The principal, if it's a dollar-euro swap, then the dollar euro needs to be actually paid to each other in the beginning and at the end. So you exchange the principal. Okay. Because of that, where do you think credit risk is highest? The credit risk is actually higher towards the end, because that's where the big principal payment needs to be made. So let's read what the curriculum says. For currency swaps, the payment of notional principal shifts the credit risk more toward the end of the life of the swap. In addition, because the payments are typically not netted, the credit risk on the currency swaps is greater than on interest rate swaps. Okay, so the 2 points to remember with currency swaps: credit risk higher towards the end, and other point is that in general the credit risk on currency swaps is greater than the credit risk on interest rate swaps. Okay. Netting reduces the credit risk in a swap by reducing the amount of money passing from any one party to another. The amount owed by a party is deducted from the amount due to a party, and only the net is paid. So all they've done is defined netting. Okay. Marking a swap to market is a process. So all they're saying here now is, if you mark to market, in which the parties agree to periodically calculate the market value of the swap and have the party owing the greater amount pay the market value to the other party. So what have they done? They have defined mark to market. If you mark to market, what happens to credit risk? It reduces. So this concept you studied in level 1 futures. Okay, by marking to market, if one party owes a lot to the other party, rather than waiting to the end to net off, you just keep netting off periodically. So if two parties get into a swap and they agree to market every month, then what have they effectively done? They have effectively reduced credit risk for both parties. The fixed rate is then reset on the swap until it is marked to market again, or until the swap terminates. This procedure forces the party to which the swap is losing money to pay the other party before getting too deeply in debt. Okay, so bottom line is, mark to market causes credit risk to come down. Okay, and finally, this is the last learning objective: define a swap spread and explain its relation to credit risk. And this is important not just from a CFA perspective, but very often if you read, say, The Economist or some other good financial newspaper, you will see frequent references to a swap spread. So we need to understand what we mean by a swap spread. The swap spread is the difference between the fixed rate on a swap and the yield on a default-free security of the same maturity as the swap. The swap spread indicates the average credit risk in the global economy, but not the credit risk in a given swap. So what does this mean? Let's say that the 5-year US Treasury, so this note, let's say, I don't know the exact number, but let's say that the yield on this instrument, just for simplicity, is 2%. If you compare this with a 5-year swap, where this swap is based on LIBOR, and then you see what the fixed rate is on this 5-year swap. If the fixed rate is 2.5%, then the swap spread is 0.5%. And the point here is that if the global economy gets worse, then what happens to the swap spread? It widens. If you recall another concept from level 1, the concept of flight to safety. So when things go bad, then people move more money into US treasuries, which causes this spread to widen. So during bad economic times, the swap spread widens. So people look at the swap spread as an indicator of the global economy. Okay, I'm going to also talk about this in a later reading on credit default swaps. So keep this definition of swaps in mind. Okay, so that is it. We are done with this entire reading. It's a relatively long reading, but what is the core theme that goes throughout this reading? Do you know? Yeah, it is swaps, but all swap valuation and pricing is based on time value of money. And what's the single most important formula to remember from here? It's the 1 minus Z4 over Z1 plus Z2 plus Z3 plus Z4. This is a Schwezer type formula, which I like more than the curriculum formula, but use the Schwezer formula to solve the curriculum questions. Okay, that's a win-win. Okay, so we've done all these learning objectives, and the key word is always practice.